So just as an intro, Paul is the person I told you about who's gotten a job in another city, and so we moved this. He was going to give us a full OHM talk in a couple months, but he won't be here. So he said, well, why don't you give a quick, at least give us a demo of what you've done with OHM, and then maybe somebody in here will be inspired to go learn it and can come give us a full talk at a later time.
That being said, the creator of OHM just got hired by Cognetti too, right?
It's true. Cognitive, yep. So yeah, I started playing around with Clojure and ClojureScript about 2 years ago, a little more than 2 years ago, and it was a hobby of mine for a long time. And I come to several meetups before I had a kid and got married and bought a house and all kind of stuff that took me away from having a lot of free time. But a couple months ago, I finally got around to playing with OHM, and I found it to be pretty cool. I'd done some other kind of medium complexity ClojureScript apps for fun, and I always had just kind of struggle with how to organize my application. And I previously used just kind of wrappers around jQuery and native JavaScript calls, and so when I saw OHM, it was pretty nice. I found it to be very, just smart about the way it does things. And I may use some whiteboard stuff to talk about some of the things that it does, but I guess I can start with it's going to be kind of a very informal demo. We'll look at some code, but I'll try to go over some principles of OHM first. So it's a wrapper around Facebook's React JavaScript library, and the big idea with React that was kind of new is it does this thing called a virtual DOM, where it constructs a virtual DOM. It's not manipulating the real DOM, which if you're not familiar with JavaScript development, it can be kind of a performance hit to just kind of mutate stuff in the DOM. And if you got something simple, it's not that bad. But if you're changing lots of state all at once and or sequentially, you can slow down your application. So the virtual DOM basically stages the updates to the real DOM, and so it has a render loop, and it goes through this this render cycle, and during every cycle it looks at the virtual DOM and it compares the new sort of application state with what has already been rendered, and I'm not too sure on the details of this, but I don't know if the comparison, if it's rebuilding a new virtual DOM every time and comparing that, or if it's just comparing the base data structures. But the point is, with Clojure's immutable data structure, or ClojureScript's immutable data structures, and if you just want to use JavaScript and use React, and there are immutable data structures for JavaScript. When it does this this calculation of what's changed in the DOM, or what is going to be changed in the DOM, if you have immutable data structures, that calculation can be very quick, because it doesn't have to parse everything in the DOM. It doesn't have to compare every level of your application tree. And I'll take a look at, for example, well, let's go ahead and jump into to my demo. Maybe you can get an idea. Let me see if there's anything else introductory to say about OHM and React first. So OHM, like I said, OHM is the wrapper around React. It was written by David Nolan, who's probably one of the lead ClojureScript developers, and he's put a lot of thought into the library. So I'm going to just jump in here. Okay, so another thing about React, and by extension OHM, is that it places a high value on building components and structuring your app as reusable components. And it's not always easy in JavaScript. People will use object-oriented based development and have this sort of concept of classes, or I don't really know. I'm not a huge JavaScript guru or anything, but we use prototypes and everything to have some sort of reusable class or object-oriented style of code. But it can be tough to really get nice, like, reusable code that kind of abstracts the right things and doesn't kind of get in your way. And so React, and by extension OM, really does a good job of letting you build components and gives you some nice interfaces to kind of isolating things inside your component that don't care about the rest of your app, and interacting, passing state back and forth between individual components, or sharing things between those components in your app. And so my little application, it's very simple. I didn't even have time to really do a good CSS, but the actual, it's an autocomplete widget, and I just kind of seeded this thing with I just grabbed all the symbols from Clojure.core as my kind of search space, and so I can just start typing in this, and M has a lot of possible completions, and I can use the up and down arrow, I can use the mouse, and click or enter, whatever to accept. Your standard autocomplete widget. And so I added I wrote this about a few months ago, where it's just the one widget. And so over the weekend and today, I tried to add a little bit more flow to it and kind of simulate, well, what would you be doing in a real application? This would probably be passing the value you select to something else, and then maybe use that. So what I've done here is the second search bar. I've got a little box here that's going to just sort of store everything that I've selected from my first autocomplete box. And then my second is just going to have pull off of that. So, and then I had intended that this last box would store the selection from this, but I've got a little bug, which maybe, I have an idea how to fix it. Maybe we can look at why it's not working. It basically involves, I haven't really scoped my state right and what needs to be done. So let's take a look at this application. So kind of what I was talking about. Okay, so another thing that OM provides is a kind of, I guess you'd call it a DSL, or just something for building DOM objects. Is that the right word? DOM elements. So there's a DOM class, or a DOM namespace that provides you with all the fundamental elements that you can stick in a web page. So you can see a little bit of a structure here. I've got a div here. This is a JavaScript literal. It's a reader macro that basically translates, or at read time, it transforms the thing behind this tag, which is a map. It will transform that into a JavaScript object, and so, which basically represents the attributes for the DOM element. And a neat thing about this library is that you don't have to use this kind of interface for building your DOM elements. You can use something like what's it called? Hiccup style syntax, where it uses it's been a while since I've done it, but it uses this sort of syntax where you've got vectors, and then you might put the attributes like this. The React library doesn't always have like a kind of one-to-one mapping to the DOM attribute. There's a little bit of transformation that happens, like class name would be class in HTML, but you get the idea. So
because class is a keyword in
exactly.
JavaScript. And this is going down to a JavaScript object.
Yeah. But React is pretty well documented. And if you ever, a lot of things you don't have to worry about. OM will handle provide some nice abstraction. But if you ever want to dig down into React and see, why is it doing this, there's some good documentation on that. Basically, everything is camel case. So again, like if you were to specify something, if you were going to add a on-change handler, if you're just doing it in plain JavaScript, you might just write .onChange all lowercase, and that's not going to translate to React and Home. But we'll look at how we call these handlers. So this is the kind of the DSL for creating DOM elements, and everything is. This is not a very good one because I've got also have some just own functions in the middle of here. So let me. See. So this file here has. This is my widget namespace. I tried to kind of encapsulate all of the component-specific stuff into this this namespace, and I'll show you how I call it and how I kind of get that reusable functionality out of this library. A couple of things to keep in mind about how Ohm handle state. So there are two types of state. I'm gonna use the whiteboard a little bit. So in your Ohm app, you've got kind of application state. And then you have, you could call it local component state. And it's kind of up to you what to place in one or the other, depending on your application. For the most part, it's going to be somewhat intuitive. For my local component state, so I'm building an autocomplete widget. It's a UI widget. I want to use things. So just to kind of point, this is where kind of I initialize my local component state. So I'm going to use things that are relevant to this UI element and aren't really part of my application. So I've got a select index. What have I selected from my autocomplete drop-down box? What is the value currently in the search bar? MD, I forget what that's short for. I'll remember in a minute. Show list, am I showing the drop-down list or am I not? The results, I've actually, I've refactored this a little bit. I decided that, so the results is what gets populated in that drop-down box. And I went back and forth and I decided that, I kind of want to handle this from the application. Maybe I want to do some more, maybe I want to make an AJAX call to, based on, based on the value in the search bar, I'm going to go, fetch something from a remote server and then put that into this component. And so I decided, maybe results should sit at a higher level in the application, but I don't know, at the same time, it could just easily be owned by this, and, I can have an interface to, if I do make an AJAX call from an application, I can, have some interface to stick the results back into there. So, like I said, it's up to you. However, you want to kind of manage this in your head and what makes the most sense for you. And I can talk a little bit about, well, how do you get stuff into your internal state, your component local state, and how do you bubble things back up to the application, to the application state. There's this concept called cursor, which is kind of just a wrapper around your application state. It seems a little bit more complex than it really is. You can just think of it as just as another as an atom, and you treat it like you would an atom. You can call, there are analogous calls for reset or swap. It has this kind of unique feature that you can grab a sub kind of tree of the main application state and pass that to a subcomponent, and you don't have to kind of worry about making sure that it just handles it automatically when you derep or kind of when you call out the bottom of a tree, or call out the subtree of the application state, and I'll show that a little bit. So a little bit more on, this is the, your basic HTML structure, and so here's kind of a little bit of the guts of this UI widget. So I've got another kind of nice thing that I like. Some people are kind of against the idea of that you're creating all these handlers in line. Basically, this is HTML, or this represents an HTML element. A lot of people would go, if you're coming from like a jQuery background, you would, pass. You just add listeners to everything after you've already kind of marked up your basic document structure. But I kind of like this a little better. It keeps everything, like things that are kind of functional, keeps them together, so okay, this is an input element. It's going to do a lot of things. I can kind of see, everything in its scope right here, and I think it's just a good way to organize code. So, when the text box changes, I'm going to process that. Go fetch my new sort of list of possible completions. When I can listen to the key down, and I've got a few control keys, arrows, tab, enter, and that's going to, if it's a control key, I've got a little bit of logic to say, okay, how do I cycle through my list, my drop-down list, on blur when the mouse leaves the drop-down box. I kind of want to handle that, hide the box. And so most of these calls are just setting the set state of the component, and I've got. So this is a callback, and this is another thing. I'll talk about this a little bit. I think there are kind of two ways to handle passing data back and forth between your outer, your root application and your subcomponents. One, you can just pass in a callback function, and when the appropriate event happens, you just call this callback function and pass it, whatever values you think are a good interface. I think the cursor is generally what you're going to be passing if you're going to handle things above you in the application, the top application scope. You're going to be working on this cursor. But in other cases, if I'm doing, if I'm handling changes in the UI, I'm pressing the down button. I want to highlight the next one on the list. I'm going to be changing the local, updating the local state, and I just pass it a function, handle the control key, and return the new local application state, and so I can display that properly. So the kind of the point of all this is I was talking about this render loop before. So this is to define an OHM component. You have to implement a few protocols, and the general kind of pattern is to use reify. You basically create an anonymous implementation of these protocols. The one that you need is either render or render state, and that just tells OHM, and by extension tells React what to do during the render loop with this component. So I'm telling it, hey, create a div, put a span underneath that, create an input box, and then I use this apply. So I'll talk about this real quick. So I've got an unordered list. So in HTML that would be a UL element, and then underneath that I have some list elements. So I've got multiple things. I'm expecting multiple sub elements there, and if that's the case, you need to use apply to apply this this outer element around each of the inner elements, and so I just use a map. This could be a map call. I use map index because I want to give each of the sub elements an index to keep track of everything. So yeah, all this is going to be called by ohm during every render cycle, and so as I'm changing things, if I change, if I capture an event, handle an event here, like on key down, I want to highlight the next list element. I'm going to update the state of this component, and that's going to trigger a re-render of this component. It's not going to trigger a re-render of my entire DOM structure, but this is where some of the performance things comes in. It knows, all right, I'm only changing this element here, and it may not even be. It's probably not going to re-render the entire element either, the entire component. It's going to figure out exactly, all right, what part of this DOM that represents this component changed, and it's going to just re-render that. And so, there's some. I haven't looked at a lot of the code, but I know, from what I've seen in some of David Nolan's presentations on the topic, it handles these things pretty well. It's pretty performant. If anybody has any questions, while I'm going through this, just kind of stop me and I can expand on something. I can talk a little bit about cursors next, and we'll kind of look at the top level application again.
Yeah, could you start at the top? I think that's the most, to get a high level picture of what it is, what you actually have to do.
So kind of, I guess a good starting point is, well, you have to declare your application state. There's no naming convention, but app state, is a good name for it. And I don't know if it's a requirement, but it's generally a good idea to model that as an add-on that contains a map. And that map is going to have, everything your application needs. I've got three components basically in this application. So I have, for each component, I have an entry in the map, and each component is going to have a few things that it needs to render, and also just to handle, like I was talking about, inter-component communication. And we can look at the flow of data and throughout this app real quick. So just to recap, this is my first autocomplete bar here. This is my second autocomplete bar, and I've also, as part of this, the second, I've got a pool of possible completions. Remember, the first one is just searching the Clojure core namespace variables, and that's what it's using for its pool. And the second one, is building this one dynamically based on what I select in the first one. So, and I played around with the two. I don't think I finished my thought earlier about what are the best way to pass data back and forth. I talked about passing a callback to where when an event happens in your subcomponent, you call this callback and it does whatever it needs to do. Another way you can handle this is use core async channels. I've been trying to follow some of this discussion around Ohm on the Clojure script mailing list, and it's still something that's kind of in development. As what are the best practices? What are the best ways to do this? I saw at one point that David Nolan had said, well, I kind of prefer using callbacks instead of core async channels. I kind of lean towards channels. I don't know. If you understand core async channels and how the data flows in and out, I don't know, it gives you just one thing you have to worry about. Whereas if you're using a callback, you have to do a little bit of, well, I need to close, this callback needs to close around these things from this scope, and I'm going to pass that down. And I think it's it takes a little bit more mental energy to kind of construct your callback that, is scoping the right things. It's not too much more trouble. Like I said, I kind of prefer the core async, but I think I think you have to be a little bit mindful of how you're creating the channels. Are you going to leak memory? Are you creating these channels in a sort of in the wrong context? Are you going to create channels and they not get freed properly? I think that's one consideration, is sort of using up resources when you're just creating channels. In general, you don't really care. Channels are pretty cheap abstraction, but you don't want to have one of these inside a render loop to where every time you go through, it's creating a new channel, and that's just gonna run out of memory really quickly. But if you're kind of mindful about how you're creating a core async channel, I think it's a pretty nice interface for passing data back and forth. And so here's our app state again. Results is an array. Results is a vector of autocomplete potential autocompletions, and so this vector is going to change every time the input bar changes. And I just have a really simple search function that is going to grab. If your search bar starts, the string starts. It's going to grab everything, and then it's going to find substrings that don't begin with a string. And I take an argument how many results to return from this little search function. So this vector is going to update based on what's in the search bar. I'm also going to be dynamically updating this pool, this vector here, which like I said, serves as the pool of autocomplete stuff for the second autocomplete bar. And then this final results vector is supposed to be updating this, but that's not really working.
So what this is your state, your app, all of the data that's being displayed on the page in one place, right?
Exactly.
Okay.
And I think, at least in the initial sort of simplified demos on Ohm, I think you can manipulate this atom directly. And I think Ohm installs a watch on this atom. I'm not positive. I kind of prefer to use the Ohm interfaces for manipulating this.
Yeah, they do that in the tutorial.
They do manipulate that directly. So if you have other pieces of your application that want to manipulate that, you can do that. It's up to you. It may not kind of handle all the optimized rendering algorithms, things like that, but for me, it's easy enough to handle everything in the context of a cursor. So a cursor is just, I'll show you, it's basically something you don't need to know how it gets created, but when I initialize my three components, I'm passing in this app state atom. Ohm/root is the way that you, kind of the top level entry point to, is basically how you attach an Ohm component to your DOM. Another thing that I kind of like about the way Ohm does it compared to something like Angular. In Angular, you have to put a little bit of stuff in your HTML you know, put an Angular attribute, or you can create, you know, an Angular, I don't know, I can't remember what it's called.
Directive?
Yeah, Angular directive. And you can create, you know, your own basically HTML element.
Can you show your HTML?
Yeah, HTML is really simple. So I've got a style sheet. I've got 3 divs. These are kind of my component entry points, and then everything else is just JavaScript to load. I'm not doing advanced compilation. I'm just using simple compilation, or yeah, no Clojure, Google Clojure compilation optimization. So kind of got to load everything in stages, and then do this require. But this is useful if you're not too familiar with Clojure script compilation. This is useful for development. You can use source maps, so you can debug directly in from your inspector, your web tools. It's really nice. I'll show that real quick. If you haven't seen that, it's pretty cool. But yeah, I mean, there's nothing in here that's specific to Ohm besides loading the JavaScript. You know, I don't have any magic, you know, words here. Everything is handled from the Clojure script, and so you know each one of these is going to attach the component. And like I said, a component just implements a protocol. It has to at least implement a render, iRender or iRender state protocol, and this is really, I haven't done a whole lot of work with Clojure protocols, but you know, it's like a Java interface, or you know, if you're familiar with that, it's just a list of functions that you have to implement. They each take an implicit, or it's an explicit argument, I guess, but for the most part you don't care about it. It's just, it takes an argument which represents the thing itself. But for the purposes of this, we don't care about what that argument is. In other contexts, if you're implementing protocols, you may be using this directly, but the key is that, well, you know, I just have to call render, and it has to return, you know, something that is a DOM element, I guess you could call it. I don't really know what the lower level React, you know, this is going to map to a React call, and you know, we can dig down deep into Ohm code if you wanted to see it, but this is basically just a wraparound, a call to React that creates, you know, an element that React knows about. It can, you know, it can use that element in constructing its virtual DOM, and it satisfies all the interfaces. So, so render or render state is going to use each one of those. Render state is going to, as its second argument, is going to use the application state, or not the application state, the logo component state. So if you need to access something from the logo component in your render phase, you know, like I did, it's kind of a little bit more obvious in the widget. I've got a big destructuring here of all the keys in my logo component state, and I'm going to use those below in the rendering of this, and then I keep track of all that. So let's continue with the thought of, all right, how are we going to, you know, kind of set up the plumbing of passing data from each component to the next one. So this top one, auto one. So here's another Ohm protocol. Will mount. It's basically, all right, this component is about to be inserted into the DOM. And, you know, let's set up a little bit of initialization.
Constructor.
Yeah, kind of like constructor. I'm really only going to do one thing in here, and that's create a core async channel. I'm going to set the local state of the component to have a channel in its state map, and then I'm going to set up a go loop to listen on that channel and receive things from that channel. And every time I receive something, I'm going to transact on the application state and add it to the pool for my second autocomplete component. So you can see how I'm sharing things, passing things from among the application state. Let me talk about the cursor again. So like I said, this is my application state. It's an atom. I'm going to call root root on my component. The thing that is going to be reify the protocols. And the second argument I'm going to pass is the application state. And then this is going to be the DOM element that I want to attach it to. And so root is basically going to expect, we can take a look at the OHM documentation on this real quick. So root takes a function of value and options. F is a function returning an instance of iRender or iRender state. F takes two arguments, a root cursor on the application state and the backing OHM component for the root. So OHM is going to really handle the transformation of this atom, and it's going to turn it into this first argument here, which is a cursor. We can look at.
But without getting too deep, I mean, the basic idea is so you've created three components, and you've got one application state, and you've got three components, and you've been able to hook them all together so that they communicate. Now your autocompletes are these different? These are different. You've created separate components for each autocomplete, right?
So
because I've heard I saw him talking a lot about component reuse, and I don't. But you didn't. You aren't. In this case, you were just just making. In this case, you haven't gotten that far where you're trying to create reusable.
So I'm reusing the.
AC input. I see.
Yeah. So this is my reusable component here, and this just takes.
So auto one would be like almost like an instance or a special case of that reusable component.
Yeah, because for auto one basically contains. Let's take a look at the DOM here. If I can. Auto one. I don't know why it's highlighting. Anyway, auto one basically encompasses the search bar and this kind of the associated in my application instance what's associated with the autocomplete. And so I've got the last thing that's selected for auto two. I've got this list here. I've got another selection thing. The actual reusable component is just this search bar here. So everything that involves changing each UI interaction, changing what's highlighted, changing how I handle keyboard input. All of that is inside a single component. This AC input, and so yeah, I've got one of those in auto one, and then one of these in auto two, and so. When I call build, so build OHM/build is how you include a subcomponent or include a component inside an existing component. So yeah, auto one is like an outer component and encompasses this span that represents what I've selected, but I'm also going to build this subcomponent AC input. What build accepts is the component, and this is a cursor here. So I'm calling get on the app and using the auto one key, and it's going to basically get this subtree, this submap of the application state, and it's going to pass that to my subcomponent. And I do this, similar thing for component two. I say, get app auto two, and it's passing this subtree. So in my subcomponent, I don't need to know, I don't have to figure out where it came from. And, that's another thing that is kind of stressed in these presentations, if you get a chance to watch any of them. This cursor here is just a slice of my application state. I really only care about, inside this component, I really only care about results and value, I think. Selected. That's what I want to pass up, or that's what I want to read out of the outer application state. And so that's, I don't have to figure out, well, I need to pass this piece of, I need to do this if this is this type of component, I need to pass it to this piece of the application, or, I don't have to worry about that.
So am I understanding correctly that this is the piece of state that makes it determine whether or not it needs to create a new virtual DOM and diff the DOM? So if something outside of that part of your app state changes, this input component and all the DOM behind it stay the same, but if something that your cursor covers changes, then it knows to call render and redo all of its work. Am I? Exactly.
So, so I'm going to dereference this cursor in a few places. Let's see, where it is. So I've got, a dereference symbol here. I don't think that's building it though. So, in any case, yeah, that's how.
So that's why keeping your whole app state in one atom isn't a big deal, because you can target. I mean, if I'm understanding,
yeah,
you can target and say like this component is interested in this state, this component is interested in this state. No matter how the state changes, it knows how to update. Or potentially, update the UI, and it does it very efficiently because it uses the virtual DOM onto the real DOM.
Yeah, exactly. So yeah, I've whittled down kind of the application state a little bit to just the piece that this component cares about. I'm going to be changing that outside of this component in the upper part of the application, but this component doesn't really care about the rest of the application state. It doesn't need to know about it. It's just going to change when it's the piece that it has kind of control over changes, and similarly when it changes its piece, it's going to render wherever else that piece of the application state is rendered.
So I'm curious, sort of to wrap up, do you recommend, like, should I'm asking, like, because I actually got to spend a little bit of time going through the demos last week, and now we're trying to think, this looks interesting for something that we want to do at work. Based on what you're using it, do you think it's ready to be used? Is it useful, or is it more just do you think of it as just a neat idea, but not ready yet? I'm actually asking because I'm curious if your opinion matches mine.
I think you have to have a little bit of being able to like snapshot like what you want to do, what you need. Like, it can be very tempting to try to stay on the bleeding edge because David Nolan's he works on this part time or whenever he gets some free time. But you'll see kind of bursts of like activity on it, and you might see something and say, oh, that looks cool. I think I can kind of pull that into my application. But you may have to do a little bit of refactoring. It's not going to be in a steady state if you're going to try to stay on the bleeding edge. But if you can pick like a good snapshot of okay, this is pretty stable, and I think it is pretty stable. I haven't run into any bugs. I mean, I'm not doing anything super large scale, but everything works as documented for the most part. And that's kind of another thing. Documentation is a little bit in flux, but there's people in the mailing list are pretty responsive. You can hop on IRC. I would consider using it.
So you're going to your Clojure job. Maybe they put you on a new project or something. You're sitting down evaluating technologies. Is Ohm the first thing that's going to come to you?
Yeah, I would probably use it just because I like the way it organizes the application, and I can hold this in my head. It reads like Clojure code. I'm not trying to wrap a JavaScript flow. I'm not trying to wrap ClojureScript around a JavaScript flow. It's a framework that's designed for JavaScript that relies on mutation. Having to set low level stuff. Like if you like Clojure and you want to have nice functional Clojure interface to DOM manipulation stuff, I think it's pretty good. It takes a little bit of a learning curve to kind of understand what these protocols are doing and understand some of these abstractions, but it's not a huge mental hurdle, I don't think. If you get some of the core concepts down, I find it to be like a good way to organize, kind of the application structure in my head.
Yeah, I mean, I redid the Pygame demo from the Mutant talk in that, and that's as far as I've gotten because I really haven't gotten too deep into it. So I'm kind of curious if after using it you're still interested in using it more, or if you're like, okay, nice idea, done.
No, I like it. I will probably use this type of structure in the future doing ClojureScript stuff.
Cool.
Anybody else have any questions?
I have a question. When you're trying to debug the stuff, since it's changing behind your back, how did you go about that? Is there does it have helper functions to help you do that?
Have you tried have you tried the React debug thing? I'm curious if that works with your app state here.
I haven't used. What's that?
There's a React debug plugin for Chrome that puts a React inspector. So if you're using React, I've seen demos where people will go in. You can actually go to your component and you can see the actual state for that component there. And I don't know how with this wrapper on top of it, like from your debug menu.
It works.
It does.
Yeah, I've tried it. Yeah.
Very cool. Because I mean, it looks great on the I watched some React presentations and it looked great. I was just like.
There was, I think, an update that came out recently to the plugin that made it so that somehow there's better interoperability. I don't know.
Yeah, I haven't used it. That'd be cool though.
Because from the demos, at least, you could go to the element and just like you've got your state, so you've got the owning element in the state, you can actually inspect the state and the properties or whatever the owning names for those are.
Yeah, it can get a little tricky when you've got several layers wrapping around the native JavaScript object. So if you're just looking from the Chrome inspector, and it's not pulling up the source at the moment, but something's wonky there. But when I started out, I was mostly just printing everything to the console, and that got me pretty far pretty fast. And then at a certain point, I don't really need to do that anymore. I've got kind of my head wrapped around it. But yeah, I mostly just do printing the console. That kind of never fails for me.
Okay. And if all your state's there in the atom, or all your app state is there in one place, it's pretty easy to. It seems like it should be.
Yeah, and there's a new. I don't remember how this works exactly because it's been a long time been a few months since I was doing all my console printing, but. This enable console print was a new ClojureScript feature that was added a few months back, and I think you can just use the println. I think instead of having to do .log js/console everywhere, you can just do println and stick your data structure in there, and that's always been my go-to for Clojure debugging, and it doesn't. It works just as well here, I think. But yeah, maybe if you're into having, maybe the plugin is like a lot fancier and buys you a lot. I haven't had a chance to look at it.
Cool.
David Nolan showed some pretty impressive benchmarks last week with this, and especially compared to like Backbone, and it seemed like an 80x improvement of just trying to do renders, and I thought that was pretty impressive.
Yeah, I've seen some of that. Some of his benchmarks. I don't do a whole lot of JavaScript performance, and I don't know if I've ever benchmarked any of my little Clojure script apps, but yeah, if he says it, I have a tendency to believe it, and I don't think anyone's called him out on it and saying, hey, you cut corners here. It's to take that.
Well, it makes a lot of sense because React uses the identity reference to do the
yes,
and so if you got immutable objects, the identity refs are going to change. And
yeah, and that's a pretty cool thing. I can kind of point out that a little bit. So, as this render cycle is running, it's comparing the last state of the application that was rendered with kind of the next state. And if I swap out something here, if I conj onto this results vector here, it's going to do a diff of the two, the last rendered application state and my new state to be updated. And it's going to do an identity check. And this here, this first map here hasn't changed. It's immutable. It doesn't have to, if the reference is the same, nothing underneath it is going to have changed. This one is going to have changed up here, so it's going to drop down to this sublayer. This first one here, if I'm changing results, this first vector, that reference is going to be the same, so it doesn't have to inspect every element of the vector here. This one is going to be different, so yeah, it's going to go in and find out, all right, well, how is this vector different? But everything else, in this tree is really quick to say, okay, this hasn't changed. If this is a mutable object, in JavaScript, and you have to basically make a backup copy of it because you have to keep a snapshot of, okay, this is what I rendered. The other copy is out being mutated by the rest of the application. I can't really track what's being changed unless I go in. I have to compare each element of this vector, or it's probably a JavaScript array. I have to compare each element of this, walk down every element of this subtree or subvector, whatever. And so yeah, I think that's kind of an obvious, maybe not obvious, but one place where immutability kind of buys you a lot there. And so there are some gains to be had for using immutability.
All right, thanks.
Okay, thank you, Alan.
So I'm going to take it you've done some own?
I have, but just mostly the demos and then some of my own
Yes.
plunking around. Sort of, I took his demo with the Datomic stuff and then kind of applied further data model to that and kind of played around with it. So.
Do you have the same impression? I'm just following because I'm trying to figure out if I should how much time I should invest into Ohm because it looks really nice. But yeah, you never know when you dig into something whether it meets the
Yeah, I mean, I've been trying to decide the same thing for one of our projects. I haven't moved forward on it yet, so it's kind of where I am in this stage of it. But since Cognitet now brought David Nolan on, he's probably going to be working on this.
Yeah, I hadn't heard that. When did that happen?
This week.
Okay.
He starts at the end of the month, is what.
Okay, cool.
Yeah, but it was on his feed like Monday or Tuesday.
Yeah.
It was like he said he was sad and then he was happy. And then like his next tweet said something about starting at Cognitect. So.
Yeah, I saw one blog post or something where they were talking about kind of, what is that, the project Pedestal, and kind of how they were sort of taking a break on that with some of this new stuff with Ohm coming out.
That's the other thing. He's on the Cognitech podcast this week, the one that just came out.
That's a good one.
So he's on there.
It seems a lot lighter weight than Pedestal. Pedestal seems like it's a very all-encompassing.
When it's very,
Right.
Pedestal's very server-side centric, and this is very client, which is why at first I was really interested in when they were talking about Pedestal and like reach out and said, oh, that's great. Oh, it's all server or whatever. That's like the opposite of where I've been trying to take things on the apps I've been working on.
I was curious if anybody had seen Hopalong as an alternative.
Yeah, I've been playing with it.
Yeah.
Cool.
It's kind of fun. When I figure it out, I'll show you guys.
Yeah.
I'm still working on it.
All right, so you'll figure it out by next month. No pressure.
I mean, I was looking at it, I thought kind of one of the drawbacks if you're getting templates from somebody, a designer or something like that, either with Solana or the Q, it feels a little funky to me. And Hopalong was one of the very few that I saw that seemed to.
Well, React, I'm wondering because React has that, what is it, that JSX?
Right, exactly.
And which supposedly, I mean, I don't know this as a fact, but I've heard from people that that's supposed to be very designer friendly.
Yes.
So I'm wondering if there's some way to merge
I
those
think somebody
in.
hasn't created the really equivalent, the true equivalent for all of
There we go, Austin Clojure Meetup project.
I think the equivalent would be like a nicer syntax for hiccup that designers won't complain about, right?
Yeah, well, that's what Solana is, but of course it's going to be different because it looks more like Clojure. And then the other one, Q or whatever, you have to use selectors to get to the point in the template where you're going to do
You mean Nmod?
to do
The client-side equivalent of Nmod?
well, I was saying Q looks like a selector,
I haven't
so
seen
you
the library.
can bundle it. You can define where in the template you want to change. which
I
is kinda
don't like
clumsy.
selector-based templates because
Yeah.
it weaves in your DOM structure with your templating, and I'd rather people be able to change CSS class names without breaking the templates.
Yeah,
I don't think that's not reasonable desire. So,
and that's what the JSX is. At the top one.
can I do a quick census? If you've ever used Datomic, could you raise your hand, please? Okay.
We just played with it?
Okay, and keep your hand up if you use it in production. Okay, just wanted to know. I moved here from San Francisco about 2.5 months ago, and we used Datomic in production. I wanted to see if, and I also wrote a migration library for Datomic. There isn't really a way to migrate data in Datomic. I just wanted to see if anybody's using it, B, if anybody actually needed to migrate things.
You want to give a talk?
I don't actually write Clojure anymore, but I could talk about why you need a migration library for Datomic, if you want to understand. Like actually explaining the migration problem would actually probably teach you guys a bit about how Datomic works.
That'd be cool.
I'd be interested.
That'd be cool.
So somebody who does
I would actually rather teach people Haskell. I'd rather spend my time doing that, but
Yeah, that's the Haskell group.
no, it's not. You don't need to teach Haskell, you use Haskell.
Okay.
I actually gave lessons on Haskell at ESF Clojure a couple times.
Cool. Well, that might be a good topic too, just as a compare and contrast to you.
It's a lot easier to convince me to do that. But if anybody's interested in using Datomic in production, and you want to know the trade-offs, pain points, pros, cons, that kind of thing, you should probably get hold of me. I'm Bite My App on Twitter. No symbols or cliffs or anything, just Bite My App. And if you think you need a historical or immutable database, just tell me about your problem and I'll let you know.
So what do you give it a thumbs up or a thumbs down for Datomic production?
I'm less keen on it having deployed it. It does do certain things really nicely. We needed the immutability and historicity because we have to be HIPAA. I work in Jags community. So we need HIPAA compliance. HIPAA compliance means you need to track every version of the state. You can't just mutate and overwrite it. You have to keep a log somewhere. It doesn't have to be fully queryable in the way that Datomic makes available. So you don't strictly speaking need Datomic, but if some regulatory official comes to you and says, all right, pull up blah, 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 timestamp, you need to be able to do it somehow. And the thing is that what most companies do is they actually kind of aren't really HIPAA compliant. They just kind of shelve logs and pretend that they could somehow pull the data out of that. But the moment you do a join and your data isn't fully normalized, doing a join on log files, good luck. I'd like to see how long it takes them to write that tool. So we wanted to actually have like queryable history, not just like archive somewhere. So that's what kind of commended the use of Datomic. The problems with Datomic are actually the peer-based design is a huge problem. And it's partly a problem because you don't really have a good way to sandbox the peer behavior. So let's say you want to do query timeouts. You can't. If you have end users, which we do, we have people writing queries because they want to like analyze something in the data warehouse. If they write a query that touches too much data and hangs the peer, the API access for everybody goes down. There's no way to do timeouts, there's no way to sandbox it. The Datomic pure client library basically gets to hijack your entire GPU, which isn't cool. This is not good. I would actually like to get back to server client-based access that takes advantage of data locality in a way that isn't peer-oriented. I'd actually rather just have like a Atomic cluster and have something more designed around that. The other problem with the pure-based access is that if you want non-JVM programs to access your Datomic data, you basically have to write one-off like APIs around your data that expose it over a REST interface. And even in that REST API, because it is itself a peer, can go down if that other program submits a query that hangs it. So this isn't really a super nice way to work with it. It's actually, there are better ways to expose data than Datalog over REST. Datalog is kind of neat, but it's really awkward for certain query patterns. What it's really good at is intersecting a series of nested joins. So if all you're doing is like intersecting constraints, and that's the only kind of constraint you need to express, Datalog is fantastic. But much like Perlog, the moment you need to say or, it gets awkward. Yeah, they have rules. You can handle or that way, but it's not really as nice. There are databases out there with better APIs than that. So in the end, would I use Datomic in? Not unless I absolutely had to have historicity. I think at this point, I would rather write database triggers than Postgres and just create a log table.
Cool.
Well,
Anybody?
I'd be curious to hear the longer version of that sometime, because Datomic's like Ohm is one of those things that seems like it really brilliant, but yet you never know how it's going to actually work out when you do it. So I would do that.
And another big point was migrations. Doing migrations in production with Datomic is fucking crazy. Like you can't, like, so in Postgres you can do like a concurrent table update and it'll safely and concurrent. Yeah, you can't do that in Datomic. So the way you do production migration in Datomic is actually the same way you do them in Elasticsearch. You create the new index and you keep trying to catch up the new index. And then what you do is you block all queries and then you flip over. You have to manage that whole cutover thing yourself. There is no like nice thing for that. So when you're using my migration library, for example, you have to manage the cutover yourself. It'll handle copying data and running your migration function to transform your data, but you have to handle the whole like blocking of queries. So for example, if you aren't running your queries through a REST API or a middleware, and it's just directly calling into Datomic to the storage from the peer, then you've got to disintermediate all of your query functions so that they know when to wait for migration cutover.
Somebody's got to decouple.
Yeah, yeah. It's like when you do like MySQL at scale, you end up like manually sharding and then putting a middleware yourself. So you have to do the same thing. So storage for scaling Datomic actually is really similar to the one for like sharding SQL databases, where you have to manage all of it middleware yourself, which is a little bit more. Because the scaling you typically use Datomic at should have nicer things than that, because you don't need to scale that from it. So you kind of get the worst of all worlds, where you don't get the nice thing of like small scales that can have nice automagic things, but you can't really like, you wouldn't really want to scale it the way you would.
Cool. All right, so in what?
That's the meeting.
Yeah, I'll do my talk next. Yeah, so I'll go ahead and get to get through this, and we'll get as far as we're interested to go tonight. And if people start looking like, well, hey, we're running low on time, then yeah, we'll wrap it up. And, we'll go ahead and get going. So what I wanted to do tonight is to take a step back for some of the people who are somewhat newer to Clojure, and look at Leiningen a little bit, look at the REPL a little bit. I found, in my experience of learning, actually going from, dabbling with Clojure to, working with Clojure full time is, I didn't really know how this stuff worked, and it was all sort of scary at first, and I knew how to do what I knew how to do, and everything else was just sort of like a mystery, and I didn't actually know how the things I was doing worked, and the process of getting getting to the point of understanding how it worked helped me out quite a bit. So that's sort of the goal today, is to go through some of this stuff and make this very open-ended. If you guys have any questions or anything you've been trying to do or any direction you want to go, I have sort of a script of things that I think would be interesting, but feel free to divert it by asking something, or if you see me doing something and there's a better way, then please please let me know. In the process of going through some of this material to prepare here, I actually learned a few things that I didn't know quite how they worked or what it did. So I think there's a lot I think there's a lot here for everybody at every level. I guess I'll ask the first question: is there anybody in here who has not used Leiningen at all that's completely new? All right, back in the back here. Leiningen's pretty easy to get started with, so I'll go ahead and get started from the very beginning. There's the Leiningen is basically all it is a batch file. So you pull it down, and I've already done that here in this home directory, and that's all it is. It's a script. You need it on your path. So let me. Okay, so and I messed up my path there because I'm really good at Unix. Path equal. There we go. Just get it there. And there's one other thing, because I'm root here. I just launched a virtual machine. I just launched a DigitalOcean machine here, and Leiningen doesn't like to be run as root, or it will warn you if you do it. So when you do that and you run Leiningen, it's basically just a shell script, and it manages everything that you need. Now to run Leiningen, you do need Java installed on your machine already. So if you don't have Java on your machine, Leiningen won't run. But assuming you have some version of Java, I don't know what I have Java 8 on this virtual machine here, or on this DigitalOcean machine. So you run Leiningen, it installs itself. Go ahead.
Quick note, you can get away with using a JRE, but if you want like full-blown Java debugging, you probably want JDK. Just keep in mind. And there is no real native debugging in Clojure, so you might want that.
Yeah, I'm trying to what did I install? I'm actually not sure which way I went with the there. So you get Leiningen, it installs itself, it installs its own jar, it installs its own version, and it can self-update itself. So once you do that, and all of that is in your .line directory. So if you're wondering where all of this stuff comes, the version of Clojure that it comes with, it's bundled in that jar. It's just a big jar with everything that Leiningen needs to get ready. So once you're there, you're up and going. Now, to use Leiningen from itself, Leiningen is sort of like a build tool, make tool, sort of a combination of a bunch of different things. When we run Line by itself, just like we did, it will tell us the tasks available to it. If you're not in a project, the main thing you can do that of interest is, there's two main things. You can create projects, and then you can start a REPL. So I'll go ahead and start the REPL here. We didn't see, somewhere up here, it would have told us where we were, so you see it up here, it actually told us earlier, it started to download some jars and other things to run. And so we've got a full Clojure environment with those few dependencies. Those dependencies come in from Maven. So if you've got a Java background, everything's the way it sort of makes sense in a Java world. If you take a look, here's a fresh, your repository is going to be wherever your Maven repository. So for on a Unix machine, it's your .m2 directory. So everything that Leiningen uses and downloads, it pushes through your Maven locally. So you can always take a look and see what versions of things you're using, what's available, and understand. Go ahead.
So if you were to do something in Maven, you can take a jar. In Clojure project, you start in that same jar. I just use the same.
Yes, it uses. So you can, if you need something, you can Maven anything you can Maven install, you can reference as a dependency from your line project. So, and we'll go through that later. You know, actually creating a Clojure project and making it depend on another one. All right, so here we are at the so here we are at the REPL, and we've kind of got this, but we're not in any environment. We're just basically plain Clojure. Clojure version is 1.5.1, right? I'll bump that up one more just to make sure. There we go. 1.5.1. This is the default version of Clojure for Leiningen, and everything inside of it. Your project itself can use a different version, but then this is what Leiningen ships with. And again, that version of Leiningen is bundled. I mean, that version of Clojure is bundled in the Leiningen jar. Okay. So I guess the real interesting thing is, okay, Leiningen is really a tool for managing your projects. So we'll create a new project. You do this line new, I don't know, something fun. So when you do this, when you do not line new in a project name, it will create a directory with this same name. And inside of there, you've got a project file and some other things. So I'm going to switch out of the virtual machine. I just wanted to show the virtual machine because it had no Maven repositories or anything, but I've got my Emacs locally. So I'll do the same thing, and now the only difference here is I'm switching to my machine where I have my version of Emacs and all my tools that I might want to use. All right, so what's in here? It creates a project file. The project file is what identifies a Leiningen project. So all of nothing else has to exist except for the project file for Leiningen to be happy. This is Clojure, so you edit it just like you would any other Clojure. I mean, you usually wouldn't want to, but you can put any you can put arbitrary Clojure in here. Usually you treat it as a data structure, but you do have the ability to add code in here. Now, when you create a project here, just to show you, it creates a couple things. It's sort of a stub project. There are other templates, and I'll show you templates later, but your base template here when you just create a brand new project is like this. Now, we could go up somewhere else and I'm imagining you've got whatever you could go create a new project by hand. All you need is the project file, but you generally will want to start from a template just to get the basics in there. So now I'm going to delete. I've got another one here. That's why. So I'm going to delete some of this stuff because it's not really interesting for us. And so get it down to a bare minimum. What you need in a project is a project name, a project version, and then you can list your dependencies inside of there. You will generally have a dependency on Clojure, but we could change this. So if we go into our now notice we're in Clojure 1.6, right? So whatever you do in your project file will be in effect for whenever you do anything in your project. And when you do run line from within a project, it will use those things. So you run line from outside of a project. If it can't go up directories to find a project.clojure, then you're outside of a project and you're just in this global scope. If it finds a project.clojure, you're in the scope of that project. So that's pretty easy. We've got a source directory, and it's just to show you, it's got a main here. It also creates it also creates a test file here. So it sort of sets you up, trying to guide you where to put things. So let's actually play with this for a second. So if we want to use it, we can do, one thing we can do is run the tests. Obviously that test that we had failed, right? We could come in here and, we could create a new test, right? So, obviously this is the, and I'll actually run it from here on test. Okay, so A test failed, B test is good. Come up here.
How do you run the show command from Emacs?
It is a meta exclamation point. So I use this a lot when I'm doing, one of the main things I use it for in project is doing this, or I might do something like, I'll show you this later, but like I want something like a, dependency list or something like that, I can run it and I've got it, right there in the editor. So, or for me it's option, I have an option shift exclamation point. All right, so, I forget if I ran this or not. One more time. In a window that we can actually see this time. There we go. So it went away, but so that's the basic idea. So it's got some knowledge about where your classes are. It puts them in the source directory. That's the default. So you may, if you come from a Java background or something, you may be used to like source/Java or something, some other thing. You can change. All of those are things you can change. But a typical project would just be source/ and then the top level of your namespace. So for instance, our class Our main namespace was monkeyballs.core, and that's going to be in source, source monkeyballs, so direct mapping. So it kind of sets you up in a right way. You'll see some older projects do things differently, but I think that's it's always better to kind of stick to the defaults because it works a little bit better. All right, so let's jump out of here and jump into the REPL, because I want to show you how we can sort of interact. And I will actually maybe split screen if I can do it and keep the REPL. Yeah. All right. So here's our code over here. Here's a REPL. I'm running it outside of it. So if I want to use this. There's several different ways to load a file in. I think the easiest one to get to from the REPL is to. Now I'm running I usually run my REPL from within Emacs. There's a mode called CIDR, right? I'm not going to do anything like that. We're going to work straight from the command line using the basic stuff. But you may have a tool like Table. You may have counterclockwise. You may have some other tool that gives you some other better way into this. But I think knowing like the base level of the tools is pretty useful. So I come into here. I'm monkey balls. That's foo. And I can make use of my code. Now if I come over here and change this, right? And I run my code again, nothing changed, right? So this isn't a hot reloading. This isn't any kind of environment to do that. But if you want to do that, I can always come back up here and add a reload on my require. Right, so that's sort of the basic way to be able to reload classes. And so if you don't have a tool like a CIDR or something that's going in and reloading classes for you, then you can always get to them, reload them. This is sort of like the development style that I used in Python or Ruby, where I have I'd open a thing and I'd load my files in and I'd access them. There's better, more interesting ways you can interact, but this is sort of like the base level. Sorry, you have one question here?
So you have the require monkey balls core where first it doesn't bring that in automatically because it's the project?
No, your namespaces are only loaded when they're used, right? Now there are some ways that you can cause it. Like if you always want certain namespaces to be loaded, then they will be. By default, you're going to start up in the user namespace. So that's namespace user. You basically have things like you have your Clojure core, Clojure tools. You have a few things loaded in the REPL, but none of your application code actually gets loaded, right? So I can actually put outside here. Monkey Balls core is loading now. All right. So save that. Start up a new REPL. All right. And so now if I run this directly, right, we didn't see anything, we didn't see our print line happening. I run this now, it's not going to work. No class found, and it doesn't know how to load, it never will automatically load something in for you. So if I load it in the first time, now you see as it loads in, then that print line, those top level things, those forms, top level forms get evaluated, and I can run this. And if I do the reload here, you see that each time it's I get the reloading message because it's actually going and doing that. Now if I had a let me create a new.
So a quick question in Emacs, when you have the CIDR loaded, I tend to evaluate, load it into the REPL with Control-X, Control-E.
Yes.
Is that the way to?
Yes, that's the way I do it too. And maybe in another time we can have a session on Emacs and some of the other tools, but I figure since that's not common.
Sure. I was just curious since you.
But yes, that's how I do it. In fact, I will do that later because I will actually connect it. So at the end of the talk, I'll actually connect into our staging application at work and make some live changes on the server, and I'll do that through Emacs because that's the easiest way to
start Emacs.
All right, are you volunteering to lead that? But there's nothing special about Emacs in that sense. Any tool, any REPL tool that allows you to evaluate a form to into a namespace would give you that same effect. So Emacs just makes it really, really easy after you've gone up that learning, after you've climbed the learning curve, then it makes it very, very easy to do. All right, so we are in a new one, so I'm going to call this probably a poorly named, but monkeyballs.test. Let me do the same thing here, and we'll create the. Copy this over, but I'll call it bar just to be different. Now, if just to demonstrate this, so if I require monkeyballs.test, right, from here, so I'm going to exit out all the way. All right, so I load monkeyballs.core. Notice that in this case, because monkeyballs core asks for something, so when you ask for something in a namespace, it will load it will load in all the things that are referenced from that namespace to the next namespace to the next namespace. But nothing that hasn't that you haven't explicitly asked for is loaded. Sorry.
It's like include.
Yeah, exactly. In fact, it's almost embarrassingly identical kinds of problems you get with with just a general include mechanism, including recursive imports and things. So now, of course, if I did, I could do the same thing here. Namespace foo require monkeyballs.core. Right? Because again, you're just the same thing. I'm just evaluating a namespace. It's actually creating the namespace, changing to the namespace, and because I've got a bunch of requires, it goes to get core. Core requires on test, and we go on down the path. All right, so let's do something a little bit more interesting here. Let's start. So the first thing we can do here. There we go. The first thing you see here is you got dependencies. So let's add something else. I was trying to find something something fun. So what is the I forgot the actual package. Yeah, this is the one. Okay, that's good. So I want this guy. That's what I'm looking for. All right, so I want to include another dependency here. So when I do this, now when I do something, when I add a dependency to Leiningen, it will as soon as I okay, no, I don't want the snapshot, sorry. I want the actual real version. Okay, so it finds it. Now I happen to already have that downloaded in my M2, so just to let me just clear this out so we can see what this looks like. So I've cleared out my local Maven cache for that, and let me just start the REPL here. So you see it's actually going out, and as soon as you interact with a project, it will check all of your dependencies, and if it doesn't have something, it will download it, right? And so here I am in the REPL, and I've actually got access to it. Now I don't have any of that. I can't autocomplete on any of that because none of that's been loaded. If I were to say I require iode viso.ansi, which is the package I wanted to use. All right, now I can, and as soon as I start, now doing this, now the REPL cannot, because those classes are loaded, it can autocomplete on them. So I can actually use some of these. So this is a little library for doing ANSI stuff, right? So I can. Right, so you can do this. So I thought this would be something we could, because you can actually play with it a little bit at the REPL, right? So I was able to add this into the project. So if I come over here, maybe I'll make another another one. So let's log.clojure, monkeyballs.log. So I'm gonna make a function called log, and then we'll have like a category and a message, and we'll so we'll just do something simple with this, and we'll print line it. All right, so we require okay, so right, so now we've created a method. We're making use of something outside of here. So let's take a step back out. And we've kind of worked at the REPL. I'm going to go back to Leiningen again and show you. Let's actually create an application, something that we can do with this. But we can work with it here at the command line. But that's we're only in the REPL when we do this. So the way we do this is. So let's create a monkey balls greet. We'll do our standard sort of hello world kind of thing. Now, if we want to create something that sort of has a main, we have to, or that has an external entry point. We'll do this with a main, right? So we'll just do this and we'll say logs. What did I call it? Log. Okay, well, that's not super exciting, but. All right, so we have this main, but how do we do it? Well, in Leiningen, you run -m and your any package that has a main. And there we go. So this is sort of how you set up and run a main. You can have any number of these. If you want to have a default one, there's a way to do that in the project. So we go back to project, and we'll just declare our main. Now, before I do this, if I do line run by itself, it will complain. There's no main defined. So main, let's call it monkeyballs.greet. There we go. So we've got it line run. Now we can do more from this. We could say create we could actually create a standalone executable. So we can do that with the Uber jar, and this creates this thing here. So now I can do java-jar. Oh, actually I can't. Does anybody know why?
You don't have a main.
I do have a main. The reason is that in order to actually do it from the jar, I have to tell it gen class. Yeah, I was going to remember. I had the same problem when I was running through this idea.
Before you do that, show us what's in the jar.
Okay, so yes, so you're going to have, it's going to be all of your Clojure files. Hold on, let me reduce the number of windows I have here because I think this is two side-by-side windows. So what it's going to do is you're going to have all of your Clojure files. The Uber jar is going to have all of your dependencies, including Clojure itself. So you see IO Aviso, you see the monkey balls. Notice you got Clojure files and a few dot classes. You got all of Clojure itself, right? But however, there's not an actual class a Java class, right? So if I go to if I look for greet in here, so you see you've got a greet.clojure, but there's no greet.class, right? So let's jump out. I added gen class here. So now let's recreate the Uber jar. So now there's a greet.class. Gen class basically tells it that create Java classes for all of these things. So once you do gen class, you can access your classes from Java as if your things as if they are actual Java things. So now when I Java-. It will work. And this will work. I could copy this off to another machine that has no Clojure, no Leiningen, no anything, and it will work all by itself. So. All right. So that's pretty cool. Now, oftentimes, hold up. Let me. So I'm going to change this so that it will now take a little bit of a message. I'm going to clean first just to make sure we don't have anything left over. So line run. Now I can pass in some arguments. 1, 2, 3. So actually, let me do this. Clojure dot string slash. I can't type. Clojure.string/join, and when we call join, do we which way is it? Well, let's find out. Do we take which one does it take? I won't use my Emacs tools there. So I have Clojure.string/join. All right. So that's a thing, right? Okay. How do we do it? There's REPL commands, and so there's doc and source. So I use this a lot, even when I'm inside of Emacs and I have keyboard or inside of anything, and I have commands to load up the docs. I find for some reason, maybe it's just because I learned this early on, but I will often come down to the REPL and use right? So for anything that you have that's a Clojure or external dependency, you can actually ask for the docs or the source for it. So here I can see that I need to pass in the separator first instead of the collection. So the separator will be a space, right? Excellent. So now we've got this. So let's in an application, one of the things I do a lot, and I'll actually show you one from work here, is at work I find that I have a lot of things that I want to do. So we have a lot of different modes that we run in. We have an API server, we have a worker, we have schema migrations, we have a bunch of different things. And each of these has different mains, right? So you're not just generally don't have just one main thing. You have lots of things. So you can do basically anything in your application that you want to create a task for. That's how I think of it. So like migrate is a task, or schema to generate the schema is a task, or worker to launch the worker, or lab to go into lab mode, which is sort of a REPL mode where we can interact with very, very specific things that we're using there. So let's go into our app here. And we'll create aliases. And the aliases are really simple, so you give it a name, and then you give it a set of arguments. So whatever you would be typing, right? Run, one. We'll just do it all as one arg. Okay, so once you create an application, so this is the same thing here, right? So so line run. So if we had run this by ourselves, or we do, now that we've created an alias, we can just do line hello, right? So this is really, really handy. I find myself every time, like you may have seen other presentations I've done, I will just create aliases all day long because they're sort of like just sort of little tasks that you want to do, but you want that, you don't need to write a plugin every time, you don't need to write a plugin to do something. And if you want to use any of your domain classes, any things in your application, you don't want to write a Leiningen plugin because a Leiningen plugin is going to run outside of your project. You just create the code, add a main, and put an alias for it in your project, and you'll be able to run it. I can create as many of these as I want, so I can do, and I can even. Again, I can not that I can imagine you actually want to do this, but. Right, I could say create a Java data object, and we'll call this time. Or now, maybe that's a better. You do line now. Right, so now it's it's giving us the time. Oftentimes
Can you pretty print that?
They have the next release.
That's right.
Yeah, did you see? They were like not happy with my fix. So Steve may put that fix in outside, so I may not actually get a commit in there unless they take my test case.
Grown.
Yeah. Oh well. Okay. So.
Yeah, I did see that.
So one thing that I find that I do a lot is I'll have several of these. So you want to do, let's say you have a test script or something like that. Well, what do you want to do? You might want to do a clean, you might want to do a build, you might want to load your database, you might want to do several things after another. Leiningen actually has an easy way to do this with the do command, line do. So we had hello, and you just separate the commands with a comma. So hello, time, right? It will do line do hello, line do time. What? I called it now. And it will run these Leiningen tasks one after another without having to restart Leiningen over and over. So if you're doing a script or something that needs to do several things, or I'll often find that I might do something like I don't know, some sequence like that where I'm doing several things over and over again, and you're being able to do those. When I discovered do, that was also I was like, oh man, this is going to save me minutes of time. It adds up. So this is really cool. So mains and aliases, dependencies, all things that I use. I use pretty much every day. The other thing that I think is really interesting that I didn't know about, and I find myself wanting to use quite a bit, is profiles. So when you run in Leiningen, Leiningen, you look at this set of properties, and it looks like it's one static thing, right? But actually it's one static thing, but you can have different modes that you're in. So when you're in test mode, you might have slightly different behavior, right? Leiningen by default has several modes, profiles, and you can specify your own profiles, and you can define what they mean. So here, again, we have this Clojure dependency. So here's a common thing here. Let's say we want to create a new profile. So what is it? Profile. And then I'll call it. And I'll just, so I create a profile, give it a new name, and I'll just say what I want to override. And it's really smart about. Nope, that's not what I wanted. This. So I want to add in a dependency in Clojure 1.6. Okay, right? Now, if I got this right, let's check. Line show profiles. All right, so here's my 1.6. Now I can actually show profiles, and I can take a look and see exactly what's overridden. So if I want to see what's overridden in the what's provided in the offline profile, right? Offline true, right? So you can actually offline. I didn't know this existed. I had no idea what's in all of these profiles and what they're doing. And I'm going through all the Leiningen code trying to figure this stuff out, and then I find out, oh, hey, it's all right here. How do we use this? Simple, line with profiles. Plus means add to the profile. So take something else and just add on the 1.6 profile. Let's just start the REPL with the 1.6 profile. Whoops. Okay, we don't have a 1.6.1. You're correct. We do. I don't know why Rich didn't get this out today for the talk, but.
That's right. I need a pretty permanent dates.
There you go. So now you can see we're running with Clojure 1.6, right? Where I could say line with profile. I mean, it's not going to look any different here.
That's faster though.
What? Oh yeah. Noticeably, that's going to save you a nanosecond.
That's right.
So if you have different modes, now a common thing is you have, let's say you're doing something and you have a couple different things going on in your application, and sometimes you need one set of some extra dependencies, maybe some extra testing, those kind of things. Adding a new closure, setting some kind of default, some different defaults like offline. Those are the kind of things that you might do with a profile. Another thing you do with a profile that I think is interesting, and so let's take a look. Line, and you can use more than one too, and you can compose them in any way. So show profiles, user, not users, user. Okay, so your user profile here, you see this line and mutant, line ancient. Where in the world does that come from? Oh yeah, that's nowhere in here. Why would a mutant be in there? Well, that happens to be because in my in my tilde dot line, I have a profiles.clojure where I added the mutant plugin and the ancient plugin. So that oftentimes there are things you want to do to a project that have nothing to do with that particular project. A mutant's not that case. A mutant's just something that you might want to use in several projects, but you might have plugins and you don't want to, you don't want to put them in every single project, right? So you can come over to your user. You can add in these plugins. You can add in other dependencies. You can add in other configurations. Another common thing, and you can customize that so that you can have your own personal configuration for each one. Another common thing that I see people do with this is to set up a dev profile, because Leiningen knows about a dev profile, but I don't believe line show profiles dev. Right, so there's nothing in it, but when you're running locally, just you as a user, you're in the dev profile. So if I put something in here, for instance, I could put source paths. This is a very common thing, dev. Okay, make sure that's getting picked up. All right, now I can come into here, enter dev. All right, so now I'm creating a user.clojure, and this doesn't become part of my app. It's part of the dev profile, so this dev source only gets pulled up when I'm operating in the project locally through Leiningen as sort of in dev mode. So if I come to the REPL for my project, and I do hello. Oh, no, it did not. Oh, because why not? Because I'm not in the user namespace. So let's switch over to that. Sorry. There we go. So when you create a main, when you go into the REPL, it actually starts you off in that namespace. So for that reason, I am going to get rid of this. All right. So very cool. So now the next thing here is how can we work with dependencies here? I didn't really quite get this until till a little bit later. Let's say I wanted to create another project that wanted to use this particular package, and I haven't installed it out into Clojures or something, right? So it's actually pretty easy. I'm going to take off the snapshot here just so we have a nice little version number here. I'm going to do a line install. Okay, so line install is going to create a jar file for the project, create a POM, and it's actually going to install that jar into my local Maven repository. So find tilde /2 name monkey, right? So you can see it's out there. Now I can come into it from another project and make use of it. So let's I'm going to create a new template, and this time I'm going to create a web application using the Composer template. So this is how you create a new project from a template. I come into right. So now I'm in a new project. I've got new things. You see some ring stuff in here. You see other things because this template has a it's created a little bit of stuff to not just to be a sort of a command line thing, but to be a web project. You see a dev profile here. You can see that it's added a plugin. It's done a few more things. And if I want to do this, I can actually we've done this in here before. So we start up the web server, port 3000. Hey, there we are, hello world, right?
You're hired.
Hey, if you need a hello world on the web, I can get that to you. Okay, so stop the server here. Let's add our dependency here. So our project was monkey balls, and the version was 010. Let's just verify that. Line depth shows will complain if it doesn't. I can actually look at the dependency tree for my app here. I can see here's monkey balls, the other project we just created, and the dependency it had on Aviso. So now I should be able to come in here into my handler, and I should be able to, for instance, let's so just factor that out, and we're going to require monkeyballs.log as log. We'll just say log/log.
Does the ASCII translate it?
Well, this is just going to be a log. This is going to go to the console. But here, let's run this line.
You're right, if it answers from the console, unless is the library sensitive to term capturing, or is it just going to end up down it?
I something I found, so I don't know about it. So here, or I guess I could.
There it goes.
So there we go. We've created, we've used it, and it's come into come in. So that, I mean, it's really quite simple to work with some of these things. If we wanted to, we could I could actually publish that out to. Now, if you tried to include monkey balls in your app, of course, it's not going to not going to load. But if I were to push that out to Clojure, you would be able to include the monkey balls logging, and then make use of that. And that's all that Clojure is. It's just an external Raven. It's just an external Maven repository. But what else can you do with that? Well, let's say you have let's say that you weren't using this. Let's say we wanted to create a new version of the ISO library. You could actually create that locally, and you could bump the version number, or you make it a dash snapshot, line install, and include the snapshot version into your app. There's another way you can do it called checkouts. I'll have to, I guess, get for time reasons, we'll have to show this. We'll have to go over that at another time. And I had a bunch of REPL stuff to go through, but given how long we ran, I think we should probably wrap this up. And maybe next time, maybe another time we'll do go through the REPL. But I want to ask before we go. Any other Leiningen questions? There's a ton more plugins. Being local versions of libraries. There's a ton more you can do, and we've really only scratched the surface. But
multi-project stuff.
Yeah, it took me forever. Once I discovered that I could line install something else, so if I need to do something, I would check it out locally. I'd just bump the version number, like CoreLogic or something, and I want to make some tests, and copy it over. Actually, let me show you one thing you can do, and this will be the last thing, and because I didn't know this until very, very recently. So cd temp. So if I make a directory, directory called checkouts, and then I go into it, and I'm going to just symlink into temps. So all I've done is there we go. All I've done is symlinked my one project in from my other project. Now, if I come into let me go to source, and I'm going to change this from green to red. Right now, next when I run this, it's actually going to pick up the change live because the ring. When you run ring in this way, it reloads projects live. But normally, what I'm really showing you is that your project picks up the changes, not necessarily that it picks it up live here. Nope, it did not pick that up. Oh, I do. I actually do need to restart it once to, because it's already got that loaded in, and it didn't know, the running version doesn't know about the checkouts. That's not on the class path.
Hey, make a quick note here.
Yeah.
So automatic app reloading in Clojure web servers applies to both Ring and HTTP-Kit. I tend to use HTTP-Kit, but I know I'm not to use Ring. A good way to understand how vars work, you can understand how they really work, quote unquote, even though they're really just like anonymous box reference things. You actually don't wrap your app, the full composed pulling away middleware and your handler's app object. If that's not boxed in another var to abstract the value from the reference, then the app reloading doesn't work, because what it's doing is it's swapping out what the var is pointing to out from underneath it, like Indiana Jones in the first movie, where he takes the bag and swaps it. That's what it's doing, and you're putting another var on your app value. If you don't put that var on the app value, then it gets a value instead of reference, and it just binds that value permanently and immutably. Yeah. So you need a var in order to be able to basically mutate and swap it out.
Yeah, the hash quote.
Yeah, I don't like that syntax because it hides the fact that really you're doing is you're calling var and wrapping it. I know why people like it, but I think it scams it.
All right, and so anyway, so that's also another way when you have a project. I find I do this. I really want it. Like early on, I had no idea how to do this, and I was just pulling my hair out. Like actually, I would actually load up classes in REPL and live change them and try to patch them. Once I realized I could actually just, if I wanted to make a change to a dependent library, I could actually do it very, very easily. Just with the checkouts, I started doing that. So that made, just knowing that alone will save you, an immense amount of time. I can't tell you how much time I wasted trying to make changes. And I think we'll call it there and go downstairs and get some drinks. I do have, if you have any questions, maybe we'll just take it downstairs and ask downstairs. If you didn't get a Keep Austin Lambda sticker, please. Some designed by our very own 4-sticker guru.